Hey everybody. Today we're doing some integrals involving trigonometric functions. Remember, whenever you have a formula for a derivative, you also get a corresponding anti-differentiation formula. Here's a table of some basic ones involving trig functions. The idea is if you differentiate any of those functions on the right, you get the one on the left. And therefore, if you need to anti-differentiate the function on the left, you get the corresponding function on the right. Here's a super simple example. Integral from 0 to pi over 2 cosine theta d theta. We need an antiderivative of cosine theta, a function whose derivative is cosine of theta. So sine theta. This is a definite integral, so we need to evaluate it from 0 to pi over 2. Sine of pi over 2 is 1, sine of 0 is 0, so overall this definite integral is just 1. Let's do 3 slightly harder examples. Here they are. Number 1. Integral secant squared 5t dt. We could do this one either with a u substitution or just kind of by guessing and checking. I'll do a u sub on the next problem, so let's just talk this one through. We know that the derivative of tangent theta is secant squared theta, so I'm expecting an antiderivative of this, secant squared 5t, to look something like tangent of 5t. Let's start with that, differentiate, and see how close we are to secant squared of 5t. Here we get 5 secant squared of 5t by the chain rule. Differentiating tangent, we get secant squared, multiplying by the derivative of 5t, that's a factor of 5. So here we're off by a factor of 5. Our integrand doesn't have a 5 in it. So we're going to cancel that 5 by including a factor of 1/5 in our antiderivative. So the answer overall is the integral of secant squared of 5t dt equals 1/5 tangent of 5t plus c. And of course, we can check our work here by differentiating that function to make sure we get the integrand back. Problem 2. Integral secant of x tangent of x square root of secant x dx. This time, we're going to use a u substitution. As always, we want to pick our u to be an inside function, a function that's inside of some other function. Typically, also, our u sub is going to be directed, we're going to want to pick a function whose derivative is a factor in the integrand. Here, u equals secant x fits both of those criteria. Now we differentiate, solve for dx, treating the derivative du dx as if it were just a fraction, and then we go back and plug into our original integral. We take out the secant of x, put in u, and we take out the dx and put in du over secant x tangent x. Now, of course, the secant x tangent x is going to cancel, and we just need to integrate the square root of u du. That's also known as u to the 1/2 du. So we anti-differentiate that by raising the power by 1 to get 3/2, and then multiplying by the reciprocal of that new power, 2/3 u to the 3/2 plus c. Finally, we need to take out u and put in secant of x. Since the problem was given to us in terms of x, it's only polite to give our answer in terms of x as well. Overall, 2/3 secant to the 3/2 x, 3/2 of x plus c. Of course, we can check our work by differentiating this. When we do that, we get 2/3 times 3/2 secant to the 1/2 x, so that's differentiating the 3/2 power, times the derivative of secant of x, which is inside the 3/2 power. And that's where we get the secant x tangent x from. Simplifying that a little bit, we get our original integrand back, just like we would hope. Problem 3. Integrate sine theta, sine of 2 theta d theta. So this time, we're going to need a trig identity in order to do this antiderivative. This is another thing to bear in mind when you're doing antiderivatives and integrals involving trig functions. Identities are frequently helpful. Here, sine of 2 theta equals 2 sine theta cosine theta is helpful. I happen to know that one by heart. At minimum, you should know that there is an identity for that you can look up if you need to. So if I take out sine of 2 theta and replace it with 2 sine theta cosine theta, the integral becomes integral 2 sine squared theta cosine theta d theta. This is another u substitution. We take u to be the inside function, u equals sine of theta, that's inside the square. Differentiate. Solve for d theta equals du over cosine theta. Next, we're going to substitute into our integral. we take out the sine of theta and we put in u. That's where that u squared is coming from. And we take out d theta and put in du over cosine theta. While I'm at it, I'm going to factor that 2 out of the integral. It's just a common factor. Just a constant factor, I mean. Now those cosines cancel, so I just need to integrate u squared du. Nice and easy. Overall, 2/3 u to the third plus c, taking out u and replacing it with sine theta, 2/3 sine cubed of theta plus c.